Dave, Rob, welcome. Gentlemen, if you're ready, we will begin this officially.
Thank you very much.
Sounds
All
great.
right, all right. Hello, well, welcome everyone to AMS Weather Band's latest webinar, Superstorm 1950, the greatest simultaneous blizzard, ice storm, windstorm, and cold outbreak of the 20th century, with David Call and moderated by Rob Littick. Before we begin, I would like to address some of the guidelines for our webinar today. If you have any questions during the webinar, please put them in the Q&A on the bottom of your screen. There's a little Q&A button to the left of the chat button. Questions for speakers submitted through the chat will not be considered. We'll have some specific time for questions from the audience after the presentation, but also depending upon the flow of the presentation, they could also be addressed within the body of the presentation itself. Now I would like to introduce you to today's moderator. So thank you, Rob. Rob Littick is the executive producer of Weather World, a statewide weekday weather magazine show produced by the Penn State Department of Meteorology and Atmospheric Science. Rob made his broadcasting debut on Weather World while pursuing his BS in meteorology from Penn State. After graduation, Rob covered nor'easters as the weekend meteorologist at WABI TV5 in Bangor, Maine, from 2011 to 2013. From 2013 to 2018, Rob was the weekend morning meteorologist at WANE TV in Fort Wayne, Indiana, covering snowstorms, extreme heat, and tornado outbreaks. In late 2018, Rob returned to where his career began to serve as the executive producer of Weather World, continuing the 40-year legacy of the Pennsylvania program and 60-plus years of weather communications at Penn State. As executive producer, Rob works with students and faculty to produce weather and climate features, along with short, medium, and long-range forecasts for Pennsylvania. Rob has a passion for working with students to polish their forecasting, storytelling, and communication skills. In his spare time, Rob enjoys hiking, checking out local craft breweries, and spoiling his cats, Toby and Ty. And with that, Rob, I give you the floor.
Gideon, thank you very much. I had to get the nod into my cats, Toby and Ty, who hopefully are watching at home. Thanks everybody for joining us tonight. I was pleased to be asked to be moderator of this webinar tonight. It actually kind of follows a conversation that I had with tonight's webinar speaker on Weather World. So that's actually a special connection that I have with tonight's webinar speaker. Not only was he also born and raised in Pennsylvania like myself, but he was also a forecaster on Weather World while working on his meteorology degree right here at Penn State. In fact, he was actually the first undergraduate student on the program. I found that out in a recent interview that I did with him on the show. You can check that out on our Weather World YouTube channel at any point in time. But he then graduated with honors from Penn State and then pursued advanced degrees in geography at Syracuse University. He now teaches classes and takes groups of students storm chasing as an associate professor of geography and meteorology at Ball State University. That's in Muncie, Indiana, which he now calls home. In January, Dave released a book called Superstorm 1950, and he's here to talk about his research involving the storm and the repercussions tonight. Please welcome Dr. Dave Call. Dave, thanks so much for being the webinar speaker tonight.
Thanks very much, Rob. I appreciate that. And thanks for your help with fielding the questions we'll get later on, as well as providing some questions of your own. Well, good evening, everybody. I'm going to start out tonight by talking a little bit about the storm itself to give you some background information about the meteorology of the storm and the impacts. And then Rob's going to take over and provide really a question and answer with it. So I'm going to go ahead now and share some pictures of the storm. I've got lots of pictures of it to share with you, and I'll use these to help tell the story of the storm itself. So Superstorm 1950, the subtitle of the book about it, the greatest simultaneous blizzard, ice storm, windstorm, and cold outbreak of the 20th century. And that title was long enough, we didn't even get a chance to put the word flooding in there. But as you can see in some pictures of the weather associated with the storm, we also had flooding as well. So a little more about the storm. It was a deadly storm. More than 350 people died as a result of this storm. Death tolls in the past from weather events were much higher than they are today. And indeed, since this storm, there have only been 2 weather events that have exceeded that death toll in the United States. Audrey in 1957 and Katrina in 2005. It was also very expensive. At the time, it had hundreds of millions in damage, equivalent to around $1 billion in damage today. Now, of course, it seems like we're getting a lot of billion-dollar weather disasters, but the way we counted damage and calculated these things in the past was different. At the time, it was the most expensive weather disaster on record. And it was disruptive. There were a wide range of record-setting hazards. It affected 26 states, comprising more than 2/3 of the United States population. In the next section, I'll talk a little about the meteorology of the storm and show some weather maps. A lot of these maps come out of Paul Cosin and Lou Ussolini's book on Northeast snowstorms. There's also some other maps that come out of a publication written soon after the storm by Smith in 1950. On the map on the left, which is from Thanksgiving evening, this storm occurred in the aftermath of Thanksgiving, we see a fairly strong cold front stretching from Lake Superior all the way down to the Rio Grande. This was a very intense cold front. The high pressure behind it from Canada was unusually cold for this time of year. A little bit of snow and rain associated with that cold front as it went through. But at this point, we don't really quite see signs of what are quite yet to come, other than the cold air is advancing across the eastern United States. As we get to Friday morning, that advance of cold air continues. We had a band of light snow behind the front, stretching from Buffalo, New York, down to Huntsville, Alabama or so. The snow did cause some travel difficulties in the south. Nashville picked up more than 7 inches of snow, a record for them for November. But in the Northeast, the snow was more of a nuisance. You can also see on the map on the right a new low pressure center developing along the front in western North Carolina. Forecasters expected this low pressure center to head off the North Carolina coast and not really be a big deal. But things changed dramatically as we started to get later into Friday. As we get into Friday, that low pressure center, well, it's still sitting there over North Carolina. The map on the left shows the position of it at about 7:30 p.m. Eastern time. What's really notable, though, about the map on the left is the high pressure center just off the map. But if you look in the top right corner of the left side map, you can see some values of pressure that are extremely high. 1044 at the very top of the map, 1040 isobar there in the northern part of Maine, a very strong high pressure center built near Labrador, and that ended up blocking the path of this storm. So instead of going out to the coast, it ended up heading northward toward Pittsburgh, Pennsylvania. Why did this storm become so intense? Well, of course, in meteorology, we're often looking at upper level charts, and the chart on the right shows the pressure conditions approximately 3 miles above the ground, so around the middle part of the atmosphere. But you notice with those lines is a giant dip toward the south across Mississippi, Alabama, and Georgia, and some very low values across Indiana, Kentucky, and Tennessee. These are near record cold air, and this record cold air really helped drive the contrast that helped enhance the storm. The other thing, which I added as a gray arrow, is the jet stream. The jet stream is flying around the base of this big trough and moving extremely fast speeds. When the jet stream's moving that fast, our processes of lifting in the atmosphere really get enhanced. So the storm became extremely intense thanks to the intensity of the jet stream and the big contrast between cold and warm air. And as I mentioned a few moments ago, that high pressure center blocked it from going out to the coast and kept it over land. The map on the left here shows the position of the storm as we got to Saturday morning. Notice the pressure of the storm is down below 992 millibars, considerably lower than it was before. The storm rapidly intensified, a condition meteorologists often refer to as bombogenesis, a little bit of a play on the word cyclogenesis. But bombogenesis is when a cyclone intensifies by more than 24 millibars in 24 hours, and this storm easily did that. So at this point, we're getting heavy rain across eastern Pennsylvania, New Jersey, and Delaware. We're getting heavy snow across western Pennsylvania, Ohio, and West Virginia. And you can see how tightly packed those isobars are across New England. We're getting hurricane force winds up there. Meanwhile, in the deep south, we're getting some wind, but we're also getting extreme bitter cold as that Arctic high pressure will build its way all the way down into Texas. The map on the right shows the weather patterns from approximately 1:30 that afternoon. The low pressure center that's now in eastern Pennsylvania is starting to weaken. Its energy is being transferred to another low near Cleveland. The other fascinating thing on this map is the position of the fronts. We have a cold front moving northward. Temperatures in Pittsburgh fell dramatically as the front went through and winds started coming out of the south. Temperatures there being in the teens, where in Buffalo, it's in the 50s. Detroit warmed up as a warm front came in from the east, but then they would cool down later in the day as the cold front came back through from the east as well. Very unusual patterns for maps. Sometimes you look at low pressures, you wonder what happens if the fronts keep spinning. Well, this is the best example of that. Meanwhile, of course, the strong winds continue. This is largely the end of the story. After this, the storm essentially drifted around in northern Ohio for a bit, setting some more pressure lows out toward Dayton, Ohio for record lowest pressure for November, and then finally dissipated over the next few days. But in its aftermath, it left a lot of snow and rain. Here's a map showing the snowfall amounts. Any place on this map in the dark red experienced more than 2 feet of snow. That basically includes almost all of West Virginia, western parts of Pennsylvania, and eastern Ohio. And again, that's 2 feet. If you widen the lens out to places getting more than 1 feet, which is anywhere in dark blue or the red colors, you're including just about the entire state of Ohio, much of eastern Kentucky, the western half of Pennsylvania, parts of upstate New York. And even heavy snow fell back into Indiana, where there was plenty of blowing and drifting, also some fairly high snow amounts in the Appalachians. You can also see on the regional snowfall index, this is in the top category for storms in the Ohio Valley region, a category 5 storm. And even in the Northeast region, where the heavy snow was mostly just confined to the western part of Pennsylvania, it rates as a category 4. So that's a little about the meteorology of the storm. Let's get into the impacts. Well, the snow, of course, was pretty notable. More than 57 inches of snow fell in Pickens, West Virginia. That was the biggest total from the storm. In Charleston, West Virginia, 25 inches fell. In Steubenville, Ohio, 44 inches of snow fell, a record for them, 29 inches in Youngstown and 22 inches in Cleveland. In Pennsylvania, Pittsburgh set a record biggest snow from any storm, even though it was November. 30.2 inches, and an eerie 28 inches of snow was enough to even slow things down in the land of the lake effect. As I mentioned before, Nashville had 7 inches, even Tupelo, Mississippi had 3 inches. With all this snow, you can imagine the impacts are pretty dramatic, and they were. In the top left corner, we see buried cars along a street in Weirton, West Virginia. This is in the panhandle of West Virginia, near Steubenville, Ohio, actually. But again, things like this were common all across the snowy areas. In the top right, we can see a snow-covered factory. Pretty much all the big steel mills, coal mines, rubber plants, and all industry in the snowbound regions ended up shutting down as a result of the storm. The only thing that was able to really move around were people walking, and to some limited extent, passenger trains between cities, but otherwise cars, transit, buses, you name it, it was shut down. In Cleveland, they called in the National Guard. Sherman tanks were able to get around, but not much else. And it was days before anybody was able to get around. On the Wednesday following the storm in Cleveland, an estimated 10,000 cars were still stuck after the storm. In Pennsylvania, they were still tangling thousands of stuck cars at the end of the Pennsylvania Turnpike, which at that time was near Pittsburgh, again, 4 to 5 days after the storm. Travelers were stuck pretty much everywhere. Many people were stuck at work too. However, people still did take care of medical emergencies and each other. The picture on the bottom right shows several mothers, many of which got assists from neighbors to get them to the hospital. People, if they got things like appendicitis, neighbors would get them to the hospital. Doctors would stay on extra shifts to do whatever needed done, whether it was a surgeon slicing meat with a meat slicer or another physician running the elevator. And it is interesting to note in 1950, people were much more willing to walk than we are these days. People really didn't have too much compunction if they needed to go out to get supplies or prescription medicines or get people to the hospital to walk several miles in the snow. Walking 3 or 4 miles to me sounds like a fair amount even under good weather. I have a hard time imagining how you do it in knee-deep snow, but people did. They walked incredible distances to get things going on. Finally, the last picture toward the right side in the center there, as traffic started to flow a little bit and the road started to become cleared in the middle of the following week, there were terrible traffic jams because all the snow is blocking parking spaces. It's very difficult for people to move around. In Pittsburgh, they actually blocked the triangle completely to all traffic. The National Guard set up more than 40 checkpoints. You can see that gentleman there trying to talk his way through one of the checkpoints in Pittsburgh. But all throughout the snowy areas, there were terrible traffic jams as things started to get moving for the following week, yet they were still dealing with lack of parking and abandoned cars. One of the more fascinating impacts from the storm was the effect on Ohio State football. They still played the game despite the awful conditions in Columbus, Ohio, between Michigan and Ohio State that day. You can see in those pictures, spectators could barely see the field. The final score was 9-3. Michigan scored a touchdown on a blocked punt that they fell on in the end zone. Michigan did not complete a single forward pass or get a single first down. Remains the only college football game where a team actually won despite not getting a first down, but the show must go on. Now, this game had an interesting postscript. Ohio State's coach had been pretty successful. He'd led the team to a 9-3 record that year in a bowl game, but in 4 tries, he had never beaten Michigan. And in Columbus, well, that's an unforgivable sin. The sports media and fans panned his decision to punt the ball, which led to the Michigan touchdown, and they essentially ran him out of town. So soon after the game, he resigned. Ohio State looked to hire another football coach, and they looked down the road toward Miami of Ohio. Miami of Ohio had played in Cincinnati that day under bad conditions, not quite as atrocious as Columbus, but still, it was cold and snowy. It was not good weather to play. Miami of Ohio won their game 28-0. So the Ohio State Board of Trustees decided to hire Miami's coach, this little-known 35-year-old young guy. Ohio State fans were a little wary, but they needn't be. The person that they ended up hiring as a result of this debacle, Woody Hayes, who, of course, if you know much about Ohio State football, led them to multiple national championships. Ohio State football continues to be a powerhouse to this day, competing every year for national championships. And perhaps if it had not been for this storm, the chain of events that led Woody Hayes there would not have led him there, and he would have gone to a different Big Ten school. Instead of talking about the greatness of Ohio State football over the years, we'd be talking about the greatness of a different program instead. So a fascinating long-term effect from the storm on college football. Snow effects weren't the only things. East of the snowbound areas in Pennsylvania, in places like Altoona and Clearfield, there was a terrible freezing rainstorm. Altoona, a city of around 80,000 people, all 6 transmission lines that fed the city failed as a result of 2.5 to 4 inches of freezing rain that accumulated. You can see in those top pictures some of the terrible tree damage. 100% of trees in Altoona were damaged. 90% of them in Clearfield were damaged. The town was basically in a blackout. The only power they had was from the Pennsylvania Railroad station, and that was essentially reserved for hospitals and emergency medical facilities. It took until Thursday before linesmen could restore even one line to power, and only 25% of the people could connect to it anyway at that point. Things finally started to thaw out late in the week, but that caused other lines to snap and break. Finally took until Friday until power was restored to Altoona and the streetlights went back on, but it took a few more weeks for electric and phone service to be restored to individual homes. You can see in the bottom picture how complete some of the destruction was to the electric grid. And also on the bottom left, you got a good sense of scale there with the one linesman putting his hand around one of the ice-encased lines. Again, it's remarkable in 1950 how well people were able to cope and adapt with this. Most people's houses were heated by coal. You didn't need electricity for coal. You just kept shoveling coal into the furnace. So many people were able to stay at home. Okay. People still would walk outside if they really needed to get supplies. And people also had a lot more ingenuity and ability to adapt things. So for example, gas stations took things like washing machine motors or lawnmower motors and hooked up giant belts to them to operate their pumps. So did farmers who needed to milk their cows. In some cases, several structures still had old gas lamps. People figured out how to light them back up. The gas company even dispatched representatives around to help people with operating their gas appliances without electricity or things like gas lights. So although this would sound like a terrible situation, and certainly it was, it caused relatively little pain and suffering, I think, compared to what we would expect with a blackout nowadays. But wait, there's more. We've got wind impacts. The top 2 pictures show some of the wind impacts in Vermont. It was considered Vermont's worst wind disaster. Both the public utility and governor called it their worst disaster on record, worse than the 1938 hurricane, which is quite famous in New England weather lore. Toward the bottom, we see some pictures of damage from elsewhere. The bottom left, we see damage from Troy, New York. Eastern parts of upstate New York, Troy, Albany, Syracuse were hit pretty severely by it. And in the bottom right corner, we see a picture of damage in New York City, where more than 407,000 people lost power, 3,000 windows were broken, And this being New York City in 1950, more than 721 building cornices fell. Most buildings are still made out of stone, but that's a pretty serious deal. It killed one person and injured dozens and messed up that car you see in the picture. More than 44 people died in the New York City metro area alone. So the wind was pretty widespread across the Northeast, but as I mentioned, worst in Vermont, New Hampshire, western parts of Massachusetts and Connecticut, and down toward New York City. New England also had to contend with some flooding. The picture in the top right corner shows flooding around Keene, New Hampshire. The picture in the bottom left shows flooding in Lock Haven, Pennsylvania. Most of Pennsylvania got 4 to 6 inches of rain, so there was a fair amount of flooding in eastern parts of Pennsylvania. A fair amount of flooding in New Jersey as well, especially southern New Jersey, where dozens of hunters died from rapidly rising floodwaters. Along the New Jersey coast, there was a lot of coastal damage from storm surge. This storm was not a nor'easter, so the winds came from a different direction than normal. They were coming more from the east or even southeast, and that caused extensive damage along the New Jersey coast. In the bottom middle picture, you can see the destroyed boardwalk near Long Branch, New Jersey. Unfortunately, a lot of people would come out to watch the wild waves, and when the boardwalk was destroyed, pieces of lumber went flying everywhere, injured dozens of people, and actually killed a person. On the bottom right, let me orient you on that bottom right picture. The ocean is toward the top of the picture, and you can see how the storm surge has rearranged all those bungalows and caused extensive damage to them. Damage along the New Jersey coast was considered as bad, if not worse, than the 1944 hurricane that had just gone through that state approximately 6 years earlier. That brings us to our last record-setting impact. This one I don't have a lot of cool pictures for because it's a record outbreak of cold. But throughout the southern United States, record lows were set, and most of these records remain untouched today. On the screen, I've got some of the different numbers. For Nashville, it was their earliest below zero temperature on record. In Atlanta, Georgia, the old record was 11. The new record completely crushed that, getting down to 3. And in West Palm Beach, Florida, South Florida, temperature got all the way down to 36, leading to this one funny news report of some tourists from New York City who decided to leave and go home because they said it couldn't be as cold down there as it was up north. Well, actually, it was pretty cold in New York City, too. In the South, the record cold caused a fair amount of losses for agriculture. It also killed dozens of people who died either from exposure to cold or in fires. Fires also did a lot of property damage. Places like the First Baptist Church in Tupelo, Mississippi, which completely burned down, or in Gastonia, North Carolina, where much of the downtown was destroyed. But I want to talk a little more about the deaths associated with the cold, and really deaths associated in general with the storm. When we look at deaths with the storm, we can see some stark departures based on race, gender, and class. Most of the people who died of exposure or of cold in the South were African Americans. In the southern United States, there was a lot of poverty, especially in 1950, and especially among African Americans who were the poorest of the poor. Many of them had no heating source at all, or if they did, it was some sort of improvised stove, which was likely to throw off sparks or just be sort of a dangerous thing to operate. So many of the people in the South who died were African Americans. There were also a fair amount of disabled people who died in wheelchairs. You can imagine a scenario where they're sitting near a stove, all of a sudden a spark ignites their clothing, which did not have the flammability standards we see these days, and that led to numerous deaths down there. In the wind areas and flooded areas, most of the victims were men. Men tended to be outside. They were out trying to save things that were being flooded. They were out trying to hunt. They were out trying to fix roofs, or they were being electrocuted by power lines or being hit by flying objects. In the snowy areas, most of the victims were also men. They largely died from snow shoveling. And if you're a male between the ages of 40 and 75 listening to this, you should get a snowblower because snow shoveling is quite hazardous if you're middle age. A lot of the other victims died of heart attacks. I mean, if you're dying from snow shoveling, it's probably a heart attack. But heart attacks also came about for both men and women who sometimes walked long distances through the snow. And there were several deaths from exposure in snowy areas, although a lot of these were more likely people that died of heart attacks and collapsed somewhere between point A and point B. Still, these tended to be men, but there were a surprising number of women that died of heart attacks, again, and exposure as well. So that was a lot of the meteorology of the storm and the impacts of the storm. One last set of impacts, it had quite an impact on a group of meteorologists. The Princeton group, made up of a lot of luminaries in meteorology like Yule Charney and Norm Phillips, they were starting to experiment with computers to help understand the equations and the workings of the atmosphere better, and also to even start to try to simulate the atmosphere. They weren't necessarily using computers to predict yet like we use them today. They're really just using them to try to understand the atmosphere better. Well, this storm affected these gentlemen, of course, and they were in Princeton, New Jersey, which dealt with a lot of heavy rain, flooding, and wind damage. And the storm was fairly poorly predicted, and it was unusual in terms of its path and its intensity. So these gentlemen started to use this storm as a test case as they tried to refine the equations of meteorology and their forecast models. And this storm continued to be used as a test case in meteorology fairly extensively for really the rest of the 20th century. It was also used as a test case in helping develop storm surge models because of its unusual pattern of wind associated with the storm. And part of the reason for the accuracy of our forecast models today is because of this storm and other case studies like it, but in particular, this one being unusual that really helped to refine our models. And one reason our forecasts today are generally pretty accurate is because our models are quite good, thanks to storms like this that have helped refine them. I've been calling this a superstorm. In the book, I talk about some other superstorms like Superstorm Sandy and the storm of the century in 1993. So how do I define superstorm? And Rob and I will talk a little more about this in a few moments. Well, a superstorm is a mid-latitude cyclone, and we have cyclones go through the United States all the time. But what makes a superstorm unusual is it has significant impacts over a very large area. The one picture behind you is Sandy, which affected much of the Northeast and Southern United States. So it has big impacts over a large area. How large? About double the size of California, or one that affects multiple NOAA climate regions. NOAA has set up 9 climate regions in the country. A superstorm also has multiple disparate record-setting hazards. And by disparate, I mean not just, say, tornadoes and severe thunderstorms. I'm talking about, things like flooding, hurricane force winds, and snow, things that are fairly different from each other. And each one of those hazards in and of itself would set records. Indeed, with Superstorm Sandy, we saw records for snow, we saw records for ice, record amounts of flooding, records amounts of wind damage and wind speeds recorded, record cold, record pressure. And finally, a superstorm should have significant societal impacts. Those can be any combination of economic impacts, loss of life, and or disruption. Superstorm 1950 easily met all 3 of those, the most expensive disaster at the time, one of the deadliest disasters, and also extensive disruption to the eastern 2/3 of the country. It's not always clear where the bar is necessarily between an ordinary cell and an ordinary storm and a superstorm, but certainly storms like this one, Sandy, the storm of the century in 1993, and the white hurricane of 1913 would clear that bar for being superstorms. So with that, I'm going to wrap up the formal part of what I'm doing. My email and my website and the title of the book are up there on the screen. And I'm going to stop sharing my screen in a moment and then let Rob take over to help moderate the question and answer part of this presentation. I'll get a quick drink. Rob, you can take it away whenever you're ready.
Absolutely. Well, Dave, thank you so much for that overview. I guess my video is not showing. Sorry about that.
There you are.
Yes, thank you so much for that overview. A lot of good in-depth analysis. I really enjoy talking about some of these memorable weather events that have impacted people. And I think this actually was one of those storms that in many cases was a little forgotten. It didn't make headlines as much as I think some of the more recent ones. Of course, a lot of people remember 1993 or a blizzard of 78, but when you're going back a little bit farther in time, it's one of those things where, hey, let's highlight this particular storm because of just how noteworthy it was. Before we get into some more of the specifics, Dave, I wanted to kind of just start things off right off the bat. And I think you've kind of alluded to this in some of the stats you gave, but what made you want to research this particular event and write a book about it?
I think a lot of my inspiration was actually what you just mentioned. To some extent, it has been forgotten. And I think some of the reason it was forgotten was it was before the modern TV era, so we don't have all sorts of crazy videos. The other part of the reason is it was a bunch of different hazards all put together. And so it didn't make the cut for the Northeast snowstorms book. They talk about it briefly, but it doesn't really make their cut because it didn't affect quite enough of the Northeast to really reach that bar. The windstorm was confined to certain regions. So you don't really see the whole scope of the storm until you start to put all these different things together. And when I started writing the book, I planned to write out basically a snowstorm, a windstorm, and a record cold outbreak. And then I start getting in there. I'm like, wow, there's a flood here. There's all this coastal damage. There's this incredible ice storm, which I think perhaps was actually the most severe accumulation of ice, even though it was very limited in Pennsylvania history. So there's just a lot more to unpack. But when you're looking at individual hazards, it's easy to lose sight of that. I will say, for those that lived through it, I've been impressed when I've talked to people. If they knew a grandparent or they themselves lived through it, they've got a story. I was just talking with somebody from Pittsburgh, and he mentioned his dad grew up in every storm when he was a kid. After that, his dad said, well, it doesn't compare to 1950, as if he was expecting another 30 inches of snow.
Well, it's funny you mentioned that. I wanted to talk about benchmarks and how, in many ways, this storm is the benchmark. And a quick reminder, I see some of the questions now coming in. Thank you for those who are attending the webinar tonight. Make sure you submit your questions in the Q&A box, and we'll get to those here in the next couple of minutes. But sticking with the idea of benchmarks, I thought it was interesting that the National Centers for Environmental Information, they have their regional snowfall index. You talked a little bit about this in your presentation, Dave. And it securely cements its first place as it ranks above their second worst storm for the Ohio River Valley, which was the March 1993 event. And so this, according to what their stats are saying here, they've analyzed 217 storms that have gone through the Ohio River Valley, and this is the benchmark. What are some of the reasons why, you mentioned all of these different, facets of the storm. But I guess when it comes to the records, when it comes to wind, temperature records, precipitation records, was it really the perfect storm?
I think it was. I mean, it's November, so we still have a fair amount of warmth left over from summertime, and of course that means ocean water is a lot warmer, and there's still just a lot more warmth in the northern hemisphere. But we had this incredible cold outbreak, which was a pretty cold outbreak by any standard. If I remember correctly, I think Cincinnati, Ohio had their coldest temperature for the entire year in connection with this storm, colder than what they'd experienced the previous January and February. So the cold outbreak was just incredible. And the fact it pushed so far south. In meteorology, storms in mid-latitudes basically meaning the United States where we live, are largely driven by contrast between cold and warm. And to have such cold air push so far south at that time of year really helped strengthen this storm. And then the other thing that really helped strengthen it was that very intense high pressure center, which developed off the coast of Labrador and essentially blocked its path. So often in meteorology, we focus on the low pressure centers and the fronts. And of course, that's often where the excitement is. But when it comes to winter storms, looking for that supply of cold air and those high pressures that may alter the storm's trajectory, and in this case, pushed it essentially back ashore, were very critical to its development. And that's not something you see particularly often. So it did give it a rather unusual path as a result.
We've got a question here from an attendee. Brian Bernard asks, have you done a comparison with the Cleveland superbomb of January 25th through 27th, 1978? It had a very similar track to the 1950 storm you talked about.
No, but that would be a good one for me to look a little more into. A lot of other storms that I did check out tended to be considerably more limited in scope. So they might have been significant snowstorms, but they weren't necessarily as strong in other aspects. One of the other storms I did look into, which I did include a little bit in the book, was the 1913 White Hurricane. That was a terrible storm on the Great Lakes, the deadliest maritime disaster in Great Lakes. More than 250 sailors died as a result of the terrific winds from that. And that was actually a pretty big snowstorm in Cleveland. I think they got more than 22 inches. So if you want to know some more about some pretty dramatic Cleveland and Great Lakes weather, that one was pretty notable. The big difference with that storm was it didn't have the high pressure to the east to block it as much. So the weather wasn't as intense across the Northeast, but otherwise in the Midwest and Deep South, it was still a pretty big event as well.
When doing the research for your book and kind of comparing it against some of the other storms, specifically with the death toll, were you able to get some numbers, and how does this stack up to maybe some other events that we've seen make headlines like tornado outbreaks or landfalling tropical cyclones?
I was really surprised that I only found two weather events in the United States after that time that had bigger death tolls, Katrina and Audrey. And Audrey was in 1957. I think it's remarkable. I mean, I thought that maybe the 1974 tornado outbreak, for example, the super outbreak, or even the more recent tornado outbreak in Alabama and nearby states in 2011. But I think it's really remarkable, a testament to how much better the meteorological enterprise has gotten at letting people know about these hazardous events in terms of predicting them, warning people about them, and how much better people are able to take actions to protect themselves. I mean, we have many more people in the country nowadays, but death amounts have gone way down. I'm getting a little ahead of myself here. Economic costs are a very different story, but we'll get to that maybe a little later. I'm
That
not
was
sure what
actually
direction you're going.
that was actually going to be my next question.
Okay.
We talk a lot about, I know on our show Weather World, but you see it through the National Weather Service or NOAA in general, talking about billion-dollar disasters. And is it safe to say that Superstorm 1950 would be classified as a billion-dollar disaster if it were to happen today?
It would be classified as a billion-dollar disaster. I mean, just adjusting for inflation, the 1950 dollars were. But if the same storm occurred today, I would hazard that it would probably be a $100 billion disaster. And a lot of that is because the value of our real estate has gone up a lot, especially coastal real estate. Along the New Jersey coast, the amount of billions of dollars that would be lost there alone, to say nothing of all the flooding damage. In 1950, you're reading about people whose houses are damaged, and they're talking about maybe 50 or 100 or maybe $500 in damage. If a tree fell and hit my house today, I doubt it would be less than $40,000 or $50,000 in damage, maybe $100,000 in damage. And so when you think of all the trees that fell in Vermont, upstate New York, Western Massachusetts, all the houses that were damaged by flooding in Lock Haven, Pennsylvania, the trees that fell in Altoona, all the pipes that froze in the deep South. It was an incredible amount of pipes that froze because, of course, they don't tend to have the level of insulation. At least in 1950, they didn't. I think you could easily get to that, but especially along the coastline. The population of coastal New Jersey has just exploded. And this is true for all coastal areas from where it was before. And that's why we see incredible eye-popping dollar figures of destruction now anytime a hurricane comes ashore, or we have a hurricane that turns into a flooding event like Harvey in Texas. It doesn't take much with the coastal real estate and with flooding these days to get to $1 billion.
Keep those questions coming in the Q&A box below. We've got a good question here from Fred Pickard. Has there been any deeper 500 millibar cutoff lows that far south since this particular storm? At least that you're aware.
I'm going to say probably not. That's really a question more for the synoptic climatologists who might be watching this. There was some research done by Richard Grum from the Weather Service office in State College, actually. I think he's now, I'm not sure if he's retired or still there.
Not retired.
Okay, but he had charted out some of the temperature anomalies, which is essentially a way of describing temperature differences from normal. And a lot of times when we're talking, we'll talk about means or averages, and then we'll talk about standard deviations, which is sort of a measure of how far apart from average you are. And anytime you're more than, in life, or anytime you're more than 2 standard deviations from average, you're getting near the end of that bell curve. With this storm, his research had found that the upper level temperature deviations were on the order of 5 and 6 standard deviations from average, which is just mind-blowing to me that it could be that far apart from what we typically would experience in November. So while I can't say there hasn't been another one, I hesitate. I doubt there has been, because that's just so far off the charts from what we would normally expect. And also the fact is these record lows have not been touched, especially in the South. And it's not even been close. It's not like, well, we were a degree or 2 within there. In the time since then, at least in November, we've not had anywhere near that level of cold departures from average.
I'm sticking with the meteorology for the weather weenies like us who are on tonight's webinar. You know, the term wasn't making headlines in the 1950s or in 1950 itself like it does now, but the polar vortex actually played a role in this storm, right?
Yeah, I mean, this was essentially a piece of some of the coldest air on the planet that broke off and moved into the southern United States. And one reason the forecasts weren't real good then was because we didn't have a lot of the tools we take for granted these days, especially the satellite remote sensing of the atmosphere. Likewise, we didn't have the robust upper air network. It wasn't until a few years later that we'd start launching weather balloons regularly across the United States. So places like the oceans and really other countries like Canada were essentially data voids. Modern forecasters would certainly recognize these ingredients, and although this storm would be unusual, they would see this scenario starting to unfold in advance. But in 1950, without that real knowledge of what was going on elsewhere, the forecasters were largely forecasting blind.
As you were doing research on this particular event, Dave, what were some of the stories that stood out to you? I know when I interviewed you for Weather World, you used the word murder.
Yes, right. So I mentioned about how it changed the trajectory of Ohio State football in Massachusetts. I think it was Marblehead, Massachusetts, in eastern Massachusetts. They were experiencing pretty strong winds in connection with that storm, as well as some spotty rain. And sometime Saturday evening, the power went out in that community. And during that time, the winds are howling, the power's out, so it's essentially a blackout. I mean, this is 1950. We don't have generators and other things everywhere. And there was a single school teacher who lived at home. She'd apparently gone to prepare dinner, and as near as the police could figure out, the following Monday, she was stabbed to death. It was a terrible looking crime scene from what they gathered. She had, multiple stab wounds, and she wasn't found till Monday morning when the milkman came by and noticed the door was ajar and walked inside. Not only that, the police even said that the murderer apparently had some time to go back and clean up a few things, like clean up bloody footprints, because they didn't find any evidence of footprints at all in the kitchen. The fascinating thing is the case is still unsolved. They never even named a suspect. There were maybe a few rumors here or there that perhaps it was a jilted lover or something like that. Although again, the police didn't really have anything to go on. So that's a pretty sad, a sad story there. Let me see if I can spin it with a better story. I've got a more fun story. In Columbus, Ohio, a woman started to undergo, signs of labor. She was about to give birth. So this was during the snow falling heavily on Saturday when they're trying to play that football game. So a police cruiser is sent out to help get her to the hospital. Well, the cruiser travels a little ways and then gets stuck in a snowdrift. So another police cruiser comes by and it starts to go a little ways and then it burns up its clutch. So a fire truck comes by and promptly gets stymied by a bunch of stuck cars in front of it. So finally, a fourth police cruiser comes by. Somehow they get her from the fire truck to the police cruiser. They get her to the hospital, and basically she delivers the baby as soon as she gets inside the building. So I found it funny, the whole relay race to get the woman to the hospital ahead of the clock. And luckily they were successful. It also points, though, to a big difference from 1950 to today. Cars today don't get stuck like they did in 1950. We're not burning up clutches or stalling out like we are in 1950. And that has big ripple effects because in 1950, as all these cars and vehicles started to fail, they blocked the roads and now the plows can't get through and more snow starts to pile up. And now there's more snow on the roads, so cars are even more likely to get stuck. So one of the big differences from 1950 to today is cars are much more reliable, tires have much better traction, and that really helps reduce the impacts of snow, as well as the fact that people stay home. When they hear the forecaster now, they stock up on supplies and they don't go out if they have to, and events get canceled. Would they cancel the Ohio State Michigan game? Well, maybe, maybe not. But in all seriousness, the NFL and other professional leagues regularly do cancel sporting events now when extreme weather is expected in terms of winter storms or hurricanes or other things like that.
Mm-hmm. Real quick, just a follow-up too. When it came to finding these stories, that of things that were occurring during the storm, were these all things that you uncovered through newspaper clippings and journals and things like that, or did you actually talk to some folks who were living through this event?
Well, a lot of them were from newspaper clippings. A fair amount of the other ones, there was a great chronicle done by Roger Pickenpaul, an Ohio local history author who went back about 20 years ago and interviewed a whole bunch of survivors. At this point, a lot of the people that lived through the storm are in their 80s or 90s. And I would have loved to include even more stories. I just ran out of room. I mean, there were those dramatic stories, but there were also smaller stories like the guy in South Carolina, I think it was, who was selling antifreeze, and he put up some notice, the meteorologist calling for extreme weather. He just bought antifreeze. How about you? And sold out within a few hours. There were other fun little vignettes like that around of people, sort of, I wouldn't say profiteering, but taking advantage of the situation. Or, the power goes out at the hospital and they operate by candlelight because, the operation still needs done, especially if it's an emergency operation. Or, oh, I do have one other story I just thought of. It's a great little crime story. This happened, I think it was near Burlington, Vermont. A man was driving his car and he came up to two men on the side of the road. Well, they held up a gun to him and carjacked him, and they stole his car. And they drove off, and of course he's angry, and there's this howling windstorm. He got a call from the police a few days later. They found his car just around the corner. Apparently, these two men had driven the car around the corner and promptly crashed into a fallen tree. So, and the car just needed some minor repairs. So, nature, I guess, meted out some justice there for the guy and took care of those carjackers for him.
Wow. We've got another question actually coming in from our Q&A bank. This one also from Fred. He says, a NOAA image showed LaGuardia flooded during the 1950 storm. Do you know what the storm surge peak was?
I'm trying to remember that. I feel like I might have put it in the book somewhere, and a lot of times I write something down and then I promptly leaves my mind. That's why I've written to-do lists
It was a
everywhere.
wide impacting storm, so I'm sure.
Yeah. I'm sure I encountered the number, especially in some of the reports on the storm surge models that were developed using the storm as a test case. But offhand, I don't recall that number, unfortunately. Well, a lot of water piled up in the west end of Long Island Sound, which is one reason LaGuardia flooded. Most of the severe damage from storm surge in that area was in southwestern Connecticut, where the coastline starts to curve and faced more east instead of south. Yeah, it was, well, you saw the pictures from New Jersey. I mean, it was a pretty solid storm surge.
Mm-hmm. Switching gears, I wanted to talk a little bit about pop culture references to the storm. Did you uncover any of those in the years or decades that followed? I know that in 1950, I had to look this up, it actually predated I Love Lucy by about a year. And at the time of the storm impacting this part of the country, only about 9% of US families probably had a TV.
Yep. And in many markets that we think of nowadays, there were no TV stations whatsoever because the FCC had a moratorium on new licenses. So most people at that point were still getting their news from newspapers, although in several areas, newspapers published radio editions because it was impossible to deliver the newspaper. It was also very challenging to get people to work or run the presses, especially in areas where there was flooding or ice. There were a lot of references in the storm in relation to the Korean War, because November 1950 was when we had made great advances across the Korean peninsula. In fact, we'd almost taken back all of Korea, and all of a sudden around the same time, all these volunteers started to invade from the north and started pushing the United States back down the peninsula. In fact, it still remains the greatest retreat in US military history. But in Korea, they were getting snow and storms as well. So there was a lot of references to that. There was also a lot of reference to the fact that, here we have this storm that's just crippling us. How are we going to deal with a nuclear threat or other sorts of war? So a lot of language of civil defense. We need to be prepared because this has shown that we can't handle a snowstorm. How can we handle a nuclear bomb? And there was also talk, we've got to mobilize the men and dig ourselves out. One area called it DO Day, as in dig out day, a reference to the D-Day. But World War II was still fresh in many people's minds, and there were a lot of military references and military analogies in connection with this storm and cleaning up the aftermath of the storm. And of course, we saw in the one picture, we even had National Guard units mobilized in Cleveland, but they were also mobilized in Pittsburgh, as you saw with the checkpoint, Youngstown, and numerous other places in Pennsylvania, Ohio, and West Virginia.
I want to touch base on lasting legacy of the storm, and you did mention some of this in your presentation, and including about the advances, in meteorology and some of the case studies that this storm really was the foundation for. But I understand that it impacted government tax policy.
Oh, yeah. So it impacted Ohio State football, of course. Another big impact was on tax policy. In 1950, we're not far removed from World War II or from the Great Depression. So many municipalities had this mentality of, we're not going to borrow. We're just going to try to spend out of, whatever funds we have for this. But it's near the end of the year, they're running low on funds. So in Pennsylvania, especially, a bunch of bureaus and governments implemented these, what we refer to now as nuisance taxes, these small little taxes like per capita taxes, where basically everybody who lives within borough limits pays like $2, or an employment tax, where again, if you have a job, you pay like $1. And they're often called nuisance taxes because they're very small dollar amounts. So in Clearfield, Pennsylvania was the best example of this. They had a very contentious series of council meetings in December, trying to put in a per capita tax to help pay for the cost of cleaning up all the trees. Because in Clearfield, more than 90% of the trees were damaged by the storm. Again, it's November. December, by the time they're starting to clean up, they don't have the money to pay for it. And they eventually settled on a per capita tax. I think it was $5. The council wanted $10. The citizens wanted $2, and they split the difference. But the next year, the authorizing this per capita tax came up again. And council again had a long debate, and they said, well, we're going to use it to pay for, city parks. And other municipalities did sort of a similar thing. Well, you can probably guess where this was going. Each year, they kept finding reasons to do the tax. And eventually, the Pennsylvania government passed a law allowing the tax to be going indefinitely. So although there have been a fair amount of counties and municipalities that have gradually worked to eliminate these taxes because they're a pain to collect. And again, they're a nuisance because of the small dollar amounts. There's still a lot of nuisance taxes that persist, especially in Pennsylvania, that largely started as a result of this storm and having to pay for storm cleanup. So another long-lasting legacy and something rather unusual.
Interesting. I know that we've talked before offline. Some of us have talked about how there was another type. There was actually a tax on alcohol in Pennsylvania that stems from the 1936 flood in Johnstown as well. Interesting how these events can impact taxes today, even. Going on, we're down to our last 8 to 10 minutes here, Dave, but I want to talk about parallels to today. And I think that the tornado event that occurred in Mississippi just this past Friday night, and your slide that you had this evening about the impacts by race, gender, and class, it's really striking, I think, the parallels between an event like this and what just happened.
I think so too. I mean, as someone trained in both meteorology and geography, the cross-training in geography is really helpful to understand how disasters impact different groups of people in different manners, how people respond to warnings. And in meteorology, we're increasingly aware of these things with our, sort of our weather and society initiatives, because forecast quality has gotten very good. I mean, the tornado outbreak in Mississippi was certainly pretty well forecast, at least as of Friday when I started paying attention to it. Yet we still had, last I heard, more than 24 people die, and that's just terrible, and that's a real shame. So it behooves us to start thinking more about what groups are really vulnerable to these sorts of extreme weather events. And as someone who studies this, I'm largely aware of it. But one reason I wrote this book and hit the message pretty hard in the book is because I think a lot of people who don't work in the weather and climate enterprise aren't really aware of the fact that disasters do have much more severe impacts on people of color, on people with lower incomes, and they tend to affect men more than women. When it comes to tornadoes, the biggest determinant often for whether or not people, live or die with tornadoes is the quality of housing they live in. And sadly, people in mobile homes are much more likely to die from tornadoes than people in pretty much almost any other structure other than a shed. And generally, people that live in mobile homes are poor. So we see that continue. when we looked at the deaths from Katrina, the overwhelming majority of deaths were African Americans. When we look at deaths from Superstorm Sandy, the overwhelming majority of deaths were men. Men are less likely to heed warnings. Men are more likely to drive around flood barriers or do other sorts of risky behaviors. As I mentioned with winter storms, men are much more likely to be out there shoveling and dying of heart attacks. There was a thesis done, a dissertation actually done at Mississippi State a few years ago that found that even today, we're still seeing men much more likely to die from heart attacks in connection with snow shoveling. So this storm helps show those effects to us, but we see those continue today with disasters, and that's concerning. And I think as meteorologists, it's worth us to try to figure out how to better connect with those communities and make sure that, we're getting them the information in the format they need so people will take action with warnings.
Absolutely. I appreciated your definition of superstorm earlier to kind of help give us some criteria when it comes to thinking about these types of events. And I wanted to take that definition and relate it to a changing climate. Do you think that climate change could play a role in making a superstorm event like this more likely, more extreme?
I think so, because there's been we're getting a little toward the edge of my knowledge, although I speak the language of climate change. Obviously, I'm not a climate change person, but we've seen some incredible intrusions of Arctic air into the United States the last few years. The thinking is that jet stream weakens a little, it actually makes it easier for extreme polar air to make it southward into the United States. We've also seen generally an increase in extreme precipitation events where 1 inch or 2 inches or more of precipitation falls. Again, we saw that with Hurricane Harvey and the incredible amounts of rain there. With all that said, I think the bigger issue for us isn't necessarily climate change making these storms more likely. It's the fact that societally, I think we are still highly vulnerable to these storms. While we can get around more easily in deep snowfalls, an ice storm, as we saw in Texas when they had that bitter cold outbreak in 2021, an ice storm is really crippling. We're more reliant than ever on electricity today. We don't have coal furnaces where we can just shovel coal in or throw a few more logs on the fire. I certainly cannot hook up my lawnmower to power my furnace during an ice storm. So, the disruption from ice would be pretty exceptional. Certainly flooding. We've built more in flood-prone areas than in the past. And as I mentioned earlier on, the amount of coastal infrastructure that would be damaged by this and the incredible expense. And although here in Indiana, that might sound like, well, no big deal. I live in Indiana. The fact is, we all pay for federal disaster relief. We all pay for FEMA, and we all pay for homeowners or car insurance. And so we need to be aware of these incredible economic costs and disruptive costs. Again, for people in coastal New Jersey or the snowbound areas or elsewhere, if they can't work and they're hourly workers, well, they don't get any money. I'm lucky to work as a professor. I have a salary. I mean, if there's a big snowstorm, I can just move my classes to Zoom. But if I worked at McDonald's or if I worked as a plumber or something else, when a storm like this comes along, I lose money for a day or 2 or 3 or 4, and I can't make that money up. So that's another sign of us to sort of think about society. How can we better take care of people that might suffer pretty severe economic consequences? Because it's all too easy if you're living paycheck to paycheck. If you lose a few days pay, well, now suddenly you're behind on the rent, or your car gets repossessed and you can't go to work, and it can be a real cascade of problems.
Yeah, definitely some lessons learned and things to think about, moving forward. Getting down to the last couple of questions here, Dave, and we appreciate everybody for joining us tonight and asking your questions in the Q&A box. Follow-ups, what are some other projects that you're working on in terms of future research? Could you be maybe doing some research on another superstorm?
I'm taking a little bit of a break from this one. I'm hoping once you've written a book, I've lived and breathed this storm for 5 years. But I do feel there's another book to be written to really tell the story of those early modelers that I alluded to toward the end, and how they really created the models that today we largely take for granted, to the point where, superintendents will cancel school a day in advance because the computer model forecast is so good that the meteorologist said it's going to snow 6 inches, and they believe him or her that it is going to snow 6 inches. So I think there's a story to be written there. If no one else goes back and does this, I'll probably like to refine that definition a little more. There is no official definition for superstorm, and I think meteorologists should come up with one, because otherwise the media and social media will just slap that term on all sorts of things that may be exciting but aren't necessarily clearing that bar. Superstorms affect such larger areas, and they strain our resources so much. I think it's worth thinking of them as a different class of storms, because we can't simply move power workers from one area to another. We need them everywhere, and that requires a different form of preparation. Finally, I'm writing a book about my storm chasing experiences. I've got a lot of tales, having been out to the plains for a few years, and I think it'll also be a neat look into some of the latest tornado and thunderstorm research. So I got a bunch of fun things on my plate.
If I'm not mistaken, it's actually about that journey to get the picture.
Yes.
Quintessential storm.
Even as a meteorologist, I figured I would go out there and just find a tornado and get this cool picture of a tornado over my shoulder, like every storm chaser, I think, wants to get. It took me a whole bunch of trips to get to that picture, more than 8 years, and I think around a dozen trips, which tells you how challenging storm chasing really is. It seems so easy. You think you just go out there, but then again, it looks easy on TV to hit a grand slam if you watch Sports Center highlights every day. But I could never hit big league pitching myself, much less hit a grand slam.
I'm sure it's a good story. So looking forward to seeing that book soon, hopefully.
Thanks, Rob.
Lastly, we've got to say, if people want to read Superstorm 1950 for themselves, how can they get a copy of your book?
You can order it directly from Purdue University Press. They give you a bit of a discount for ordering it from them. Of course, like every other book these days, you can find it on Amazon. If you simply search for Superstorm 50 and David Call, it should come right up. There's also links on my website, drdavecall.com. And of course, you don't have to get it from Purdue or Amazon. You can get it from your favorite local bookseller, or wherever you get books.
Awesome. Dave, thank you so much for taking time out of your evening to do this webinar, talk about your research of Superstorm 1950 and its parallels and repercussions to today. We really appreciate all of the good discourse tonight with some of the folks who have joined us and weather weenies out there. And with that, I'm Rob Leidick. I'm going to sign off, and we're going to turn things back over to Gideon at the AMS.
Well, thanks for having me, and thanks for hosting, and thanks for all your questions. The audience questions as well. They were great.
Well, hey, Dave, Rob, thank you so much for joining us this evening, and audience, thank you also for joining us. All webinars will be available to Weatherband members at amsweatherband.org. So, folks, if you have further questions, or if you want to talk about the webinar, members are welcome to discuss on the Weatherband Community Forum. And with that being said, also, please check out our chat. I put a message there. Consider joining our AMS webinars mailing list to hear about all of our upcoming webinars. But yes, with that being said, I would like to bid everyone adieu. Again, Dave, Rob, thank you so much for joining us this evening.
You're welcome.
All right, take care, everybody.